This conference will now be recorded.
Hello. Could someone confirm if you're able to hear me? Okay, thank you. And
Yes,
also let me
Kiran, we
know.
can hear you.
Okay, yeah. Just wait for one more minute and we'll get started. Right, let's get started. Okay, so okay, as you all know, this is um, yeah, this welcome to the demo session for DevOps with Azure. And firstly, let me introduce myself. I just wanted to keep it, in a rather not not a boring way. So I put it in a different way in how we write our technology. So I put it myself in this YAML format. So my name is Kiran Kumar. You may all call me as Kiran. And I have a total experience of 13 years, and out of which 7 years as a DevOps engineer and as well as an SRE engineer. Okay, and my expertise cloud and infrastructure as code, apart from other technologies like container and the orchestration. What are my interests? I'm interested in the latest technology and I love training. Okay, I've given several trainings in the organizations where I worked. Okay, so I worked with an MNC and then I worked with an ML based startup as a uh, SRE, site reliability engineer. Now I'm working as a DevOps engineer in another startup. That's about me. If you have any questions, feel free to interrupt and ask. Okay, so what's our problem statement? Why do we have this course? Okay, so let's see. So what this course aims to do: understand the world of software development lifecycle and IT operations. Know why and how DevOps is adopted. Get understanding of various steps in application development lifecycle. Learn the usage of right tools to achieve each step with efficiency in a timely manner. So this is what we are going to do. We are going to understand what's how software development lifecycle looks and how IT operations works, and why and how DevOps is adopted. Okay, we are going to of course focus a lot on how is DevOps done today. Okay, and of course get understanding of various steps in application deployment lifecycle and effective usage of your tools that we are going to learn. Okay, so before we further discuss about what is there in the course, I just want to give everyone a overview of how IT operations works, like a very high level overview, 3,000 feet view. Okay, so not going into details, but how things work in IT operations or uh, IT in general. Okay, so first let's talk about application lifecycle, how application lifecycle works. So we all use software, but at the beginning, whatever software you're using today, be it YouTube, WhatsApp, or any other web service, it is in the form of code. So first, developers build code and save it in a source code repository. Okay, so they save it in a central location. All the developers keep writing code. Code is nothing but in the form of letters and symbols. Then this code is compiled into a binary file, an executable file. Okay, this is called build process. So for instance, when you're installing some application on your Windows, you install a .exe file, right? That could be called as an binary, as an a compiled file. Okay, just give me a second, guys. Okay, sorry about that. All right. So once the developers write code and they save it in a local, in a central repository, this is compiled into an executable file or a binary file, and this is called build process. Next thing is the IT operations folks create create networks and servers to run the binary created in the step two, or rather, they will create the infrastructure where your code is running. For instance, today we are all accessing WhatsApp. So when I'm sending WhatsApp message, it doesn't directly come to you. It has to go to WhatsApp servers. Okay, we might have heard of the term servers a lot of times. Okay, right? So who does that? The IT operations folks create servers and all the networking details through which we can interact with the servers, and through that server we can interact to some other user. For instance, today I'm talking to you over a go-to meeting, but this go-to meeting, we are not doing it directly, my laptop to your laptop. Instead, from my laptop, it will go to the go-to meeting server, and from the go-to meeting server, it will come to you, right? So this is the infrastructure part. Next thing is the servers will be configured to run the built software. For instance, in this step two, we have built the uh, built an executable using the code built created by developers. So in this step, we have to also have additional dependencies to run that software. So this is again also done by the IT folks, IT operations folks earlier. Now the binary files created in step 2 will be deployed in the infrastructure created by IT ops. Next thing is, okay, now you deployed your application, now you started testing. The next thing is to make the application available to public. So this is called releasing. You release your software to public, like you say, okay, my WhatsApp is now available to download from uh, Google Play or App Store or wherever. Next thing, what's next? So IT applications can go down anytime, be it a software issue or a hardware issue. So you need to constantly monitor them, maintain them, upgrade, and also make new releases again and again. So that's the application lifecycle in a very high level overview, not going into details. Okay, why am I giving this? I'll come to it in a minute. Okay, so this is a again a very high level view of what happens in the applications development lifecycle. So first, this is where the development process takes place. What is development? Writing of your code. Then it is pushed into a central location. It's called a source code repository. Okay. Then from the source code repository, you have something like a Jenkins, which will pull the code and build your artifacts or executable files. So from here, you will deploy your code. See this dotted line into QA first, then stage and production. What is QA, stage, and production? So when you write an application, uh, or when you build a new app like Flipkart or Amazon, you have to do a lot of testing before you open it for public. So where do you do it? You will not do it on the production servers. And what these stages mean is, what these environments mean is, they have these will contain their own servers. Okay, so this is for testing. This is also for testing, but staging is always similar to your production environment. Why? Because before you release to the public, you want to test the exact replica of your production and see if everything is working well. Then you will put it in production, and this will be open to your public. Okay, in each of these blocks you will have servers. Okay, you might have two web servers, two application servers, two database servers. And don't worry if you don't know about anything about servers or application database and everything, we'll cover all of those things. Okay, but even to build these applications, we use tools, automation tools like IAC, or infrastructure as code, using which you build servers on these three different environments. Again, I covered another point. Even to build this, even to install this software, you will need some prerequisites, something like Java or .NET frameworks that you need to install. So that we use in what that we deploy using SCM, software configuration management. So software configuration is management is used to configure all the servers. Your IAC is used to deploy the or create the servers, and Jenkins is used to push the code or executables to all your environments. This is again a very high level overview. Okay, just to give you a perspective about IT world. Okay, and trust me, we'll talk about all these things in our course. All right. So so far, what's happening is we have been using all these servers in a private data center. Private data center is, for example, your organization Flipkart. You want to run your application somewhere. Where do you run your application? You run on your servers. So for that, what you will do, let me let me take a drawing. Okay, please do interrupt me if you have any questions. You can stop me and ask for anything. Let's say you want to run your own application. So first you create your web servers. Then to store all the data, for example, your user data and your details, you need a database. That's fine. Okay, this is your web server where users will directly connect to it and get the web page. And maybe you should also do some logic. You should also apply some business logic, like if some person is purchasing this from so and so application, so and so, what you call, promo code should be applied, and so on and so forth. So you will you will always have any of these three servers, or sometimes if it's a simple application like Wikipedia, you might not even have a app server. Again, what is this? This is nothing but a computer with a better capability. Server is nothing but a computer with better capability. Okay, where are these hosted? Again, Flipkart buys a storage room or data warehouse, or rather a data center, and they put all the servers there. Okay, and they run these servers. They maintain they maintain for cooling and all that thing. But in IT world, anything or in anywhere, systems go down, right? Go down for whatever reasons, hardware issues, network issues, and whatever issues. So what happens if there is a failure in one of the systems, meaning this system has gone down? Then your application is down. Even if your database server is running, your application server is running, the web server itself is not running, it's gone. Okay, let's say, in another example, your DB is gone. Okay, your DB server, when I say gone, it's shut down, accidentally crashed. Okay, then what happens? You'll receive connections, but you don't get any user data. So maybe users cannot authenticate, meaning they cannot log in. So that's why we need multiple servers of the same type. So having one web server is not enough. You need to have more than one web server. Similarly is the case with app server. One app server is not enough. You need to have more than one app server. These are called redundant servers, meaning same configuration but more than one server. Okay. So is the case with your DB servers. I mean, I'm just giving an example. Sometimes you might have more than, I mean, three is a very minimum number required. No matter how good your server is, you need to have more than one server. Okay. Then you need to have something to manage the load. This is called as load balancer. You will have something called as a load balancer, and your users will come out from internet. Okay, internet is generally represented through a cloud, so I'm drawing this. So all the users will come from here, and they'll talk to the when I say talk to, they'll reach to the load balancer. From load balancer, they'll talk to all these web servers. Okay, so this is all need to be set by the Flipkart only. They have to buy one big storage location like a godown and put all the servers, put the cooling, put redundant power. Because what if the power has gone down? You need to have generators to have backup power. You need to also have redundant network connectivity. What is redundant network? For example, you have act cable or Airtel. You might have noticed it will go down anytime. It's okay to go down, internet to go down in our homes, but in the Flipkart data center it cannot go down, right? So they need to have redundant network connectivity as well. So all this you have to continually monitor, manage, and also keep security, both physical and also network security. Let's suppose Flipkart introduce, yeah. So this is the traditional data center. Next came cloud. Okay, let's go and see what's cloud, because we are going to discuss Azure, which is also a part of, which is a cloud offering, and we'll see why cloud is required. So cloud computing is the on-demand availability of computing resources without the direct active management by the user. In other words, cloud is a collection of data centers managed by cloud providers, and users can rent resources on a pay-as-you-use model without the upfront costs. So does it make sense, or is it really? So one thing is on-demand availability of computing resources. What is a computing resources? It could be a server, it could be a network, it could be a load balancer, without the active direct management by the user. Meaning, I shouldn't call Azure today or AWS and say, hey, I need two servers. Or I should not chat with them and say, I need two servers. You should be able to create servers on your own just by going to a website. That's the uh, without the direct active management by the user. Okay. So cloud is a collection of data centers managed by a cloud provider. Cloud is nothing but it's managed. It's a group of servers managed in different locations, and you get a central interface like a website to to access your resources. And users can rent resources on a pay-as-you-use model without the upfront cost. Okay, let's go back to the earlier example where where Flipkart has to set up their own web servers. So suppose the Flipkart founder had an idea and he need to run this code. First, developers will build the code somewhere here. Let's say developer team is existing outside this block. They're running on their own laptops and they're building their code. But at the end, you have to build the code and build it on your servers. Further, what you need to do, you need to hire a big room. We call it as data center. Then you need to buy servers. This is all upfront cost, meaning even before your application is going live, you have to spend on all these resources, right? But cloud, you can start using it and pay after you start using it. Okay, it's like your postpaid. So you need not pay anything upfront. Only once you start using it and once you start billing, you can paying it. So there's no upfront cost. So if I'm a small, if I want to start a small retail website where I want to sell food items made by my mom, so I need not worry about where to build the server and how to build it. Cloud will give me those server. I just need to create it and start using it. Okay, that's cloud. Okay, before we go into much deeper details about cloud and DevOps, let's also talk about why cloud has become so important these days. Okay, I always give this analogy. Analogy is nothing but a comparison. Let's say We'll talk about in terms of real world analogy. Let's say you are a retailer, okay, and you have a godown, okay. You took it for rent, and this is, let's say, 100 square yards, okay, 100 square yards. Next, but you know that most of the year you only use, let's say, 40 square yards or 40% of it, okay. From April to, let's say, September, you use only 40%. And then from December, Christmas season and all the festival starts till April, till all the festival ends, you have to stock up more. So let's say you're using till 70%. Okay. So throughout the year, like from most of the year, you're wasting 60% of your resources, 60% of your space, but you're still paying the rent. Okay. And even in your busiest season, that is December to April, you're still wasting 30% of your space. But you cannot take only this much space, because when the season comes, you have to look for this space. Okay, you need to have this additional space, maybe because in the next year, if the demand increases, you might have to go up to 90% utilization. So in real world, we cannot really do anything about it. We have to take that risk, and or take that you know we have to pay that additional price. But in the world of computers, so this concept of cloud has come. Okay, let's say Flipkart is using 10 server instead of area. Now we'll talk about servers. Flipkart is, let's say, using 10 web servers, 10 app servers. I'm just giving a random number. It doesn't mean that they are using 10 web servers today. 10 DB servers. Okay. And they plan to announce Big Billion Day. Big Billion Sale is like everyone wants to keep on buying. So they know they have to increase it to at least 5 times. So 50 web servers, 50 app servers, and 50 DB servers. So in the real world, I mean, if you're maintaining your own infrastructure, if you're not going for cloud, what you need to do is you need to buy all these resources. Okay. Let's say you increase from 50 to 10 to 50, but these are actually physical assets. Okay. You have to buy them and keep them in your data warehouse. You have to keep power for them. You have to have network connectivity. You have to have cooling and all that stuff, and physical security. You have to have security and monitoring everything. Let's say the Big Billion Day sale is over after 10 days. It's a grand success. Now users have come down. Now only earlier every minute five users used to log into Flipkart. Now only two users log in, or rather one user log in for every 5 minutes. So now your demand has come down to the old scale. So you have to again shut down all the 40 web servers, but you still have your 40 plus 40 plus 40 lying somewhere in your data center. And these are not like your wooden logs or some old clothes that you could discard somewhere. These are servers, so these should be maintained. You should make sure that they are properly cooled. They're shut down though, but you still need to maintain their upgrades every now and then, because when you power them on back after your Big Billion Sale, you should not have old software. So you have to power them back up and again do upgrades, shut down. It's a lot of maintenance, right? Your storage space is also used, or when I say storage, actual area in your data center. And also you need to have a lot of management for this. So now comes cloud and says, hey, you don't worry about how where to put your servers. Just come to my website and build your servers. Okay, let's say you need only two servers today. Just build them now. Just come to Azure or AWS, build two servers. Okay, your scale is increased to 10. No worries. You can, within a few minutes, you can just like this create 10 machines, 10 servers. Okay, you can go on. Okay, so today you launched with two servers, and after 1 month, you launched six servers. So for the first month, you will only pay for this one server. And after the first month, you started six servers. You will pay for six servers for whatever time you're using. Let's say you're using from for 1 month, one additional month, six servers, and later you're using only four servers. So for only that 1 month, you will pay for the six servers. For the rest of the year, you will only pay for these 4 servers. Okay, you think this is also too much, your load is not that much, you can delete one more server, you can run only on 3 servers. But tomorrow a requirement has come, same application for a different client, let's say, or a different location, then you can replicate the same environment within no time in a different region. Okay, so that's cloud. That is the on-demand availability of resources. Just like you just think about it and go to the website, you can build resources. Okay, and also pay as you go model, meaning pay as you use. You'll pay only after you start using it and only after you start running your applications. So there is no upfront cost, and the scalability is very high in the sense from 10 servers to 100 servers you can go in a few minutes. Okay, you could also have much more security, because underlying security, not the application security, because these services are running on a large scale. Okay, they're serving thousands of customers, so they make sure they have very high security in place. Any questions so far about cloud? What is cloud and why it has become so ubiquitous or so prevalent today? Okay, that's cloud, right? Next thing is, this course is all about DevOps with Azure. So we are going to learn some Azure and some DevOps. So let's see what's actually DevOps is. Okay, so if you remember the earlier diagram, um, this one. So developers used to develop the code, and then they would just check into their source code repository or a central location, and then operations folks used to come in and run this thing. So they used to work like two separate teams which have no connection in the earlier days, before like 8 9 years. Now what happened is, people understood that this is creating a lot of problems. This is not helping in creating faster releases. So then they started doing something called as building a new practice of DevOps, where development team and the operations team, this red circle you could call it as the, sorry, operations part, and this you could call it, or rather this, the first half, or rather this is the DevOps dev team, and this is the IT operations team, and you will have QA somewhere. But with the advent of DevOps, what happened is the development and operations team work closely from day zero. They also work with the QA team, understand the requirements, what is required for the application, how to set up the infrastructure. They'll talk from day zero and work together as one team. So that's the concept of DevOps, to work as one, operations and development teams coming together along with QA team to understand the requirements better, to suggest what is the infrastructure they're going to use and keep using it. Okay, so let's see the theoretical definition of DevOps. DevOps is a set of software development practices that combine software development and information technology operations to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. So, what is the business objective of any organization? The business objective of any organization is to do better in the market. For example, if today you have uh, WhatsApp, it wants to beat Telegram, it wants to beat Hike and whatever other products are there in the market. So what should it do to beat the competition? Any idea? Okay, we'll talk about day zero. In computing, everything starts with zero, right? So you'll not start with one. So day zero is nothing but day one. Yeah, that's one question I received. So anyone, what was my question? So what should WhatsApp or YouTube or any other software application do to stay ahead of competition? Okay, why do we use WhatsApp? One thing, ease of use, meaning you can easily use it. Second thing, features, like you have statuses, you have gifs, you have gif or gif, whatever, however you call it. You have voice messages, you have swipe to reply, and all these features are available in WhatsApp. That's why we are using WhatsApp. So one thing is, you have to create a user friendly software, and also it should be feature rich, meaning it should have very a high number of features with easy access of use. So, but if you remember when the WhatsApp was launched back in what 2012 or 2013, it did not have all the features, right? It had only text messages and maybe image sharing. Image sharing was also not there, I guess. So later they started introducing a lot of features. So if you want to stay ahead of competition, what you need to do is you have to release your updates faster, sooner. So how is this going to happen? Developers can write code faster and they can build it, but you have to take it to market, meaning you have to deploy it in your servers and take it faster. So this is where DevOps comes in. So DevOps aims to bridge the gap between development teams. Development teams are nothing but programmers, guys. Programmers who actually write the programs. And the operations team are who manages the servers, who take the code and build it into executables and deploy that we discussed earlier, right? So for this to happen, you need to have better practices, better coordination between the development and operations team should know what's happening from, as I said, day one or day zero, however you want to call it, and start integrating this code into your release pipeline. So this is achieved through a different set of practices. Like, okay, now so earlier they used to like work, developers used to work in a separate team. Operations team don't know what they're doing. They used to build code, write code, go on, and once before the release, they will tell the operations folks, okay, tomorrow there is a release, be ready. And these guys are in a shock, so they don't know what application it is, what infrastructure it is. But today, right from the beginning, both the teams work together. Okay, they build, they know what's happening, and they work in sync. So in this way, they are able to release the software faster to the market. Okay, that's the main objective of any business running IT infrastructure, IT today. Okay, any questions on DevOps? What is DevOps? I mean, we'll still go in deep dive into DevOps. This is only just a very high level overview. Do I take that as no questions? All right. Okay. Next, the important part, why you are all here. What are we covering in this course? Okay. So again, I made it like little non-boring. So I put it in terms of some JSON files or Terraform files for you to give you better understanding. So I'll talk about each section, what is covered in each section. So first section is introduction. I mean, when we start the actual batch, this is only a demo. So we'll talk about IT operations, how it was there and how it is working now, and what's cloud, the overview and what are the characteristics of cloud, and DevOps, what is DevOps and why. We'll take a deep dive into DevOps. And the next section we are going to focus is on IT infrastructure. So what are the various types of IT infrastructure that you have today? Okay, so you may be a DevOps engineer with Azure knowledge, but sometimes you might also have to manage your own data centers. Like your company might not be completely on Azure; it might be only a part of it. So we'll understand how IT infrastructure works, what is the design, and what are the networks, subnets, and inventory. And today, predominantly all the servers that we talked about run Linux. Okay, Linux is an operating system. You might have heard of it. So we are going to learn Linux, what's its history and what are the distributions and the management part. How do we manage files? How do we manage disks? How do we manage packages, processes, services, and networking? Okay. Again, guys, this is not a detailed view. This is only a high level view, but so many things come into each of these. Then we talk about scripting. Okay. How do we script in Bash or Linux? Next is the important part, of course, cloud. So what is the history of Azure and what is its infrastructure today? And what are the services we are going to learn? We are particularly going to learn about IaaS. What is IaaS? It's not a Azure specific term. It's a IT specific term. It's called infrastructure as a service. Okay. So today, cloud offerings provide provide a lot of offerings. Like we have something called as IaaS. We have something called as PaaS, and we have something called as SaaS. So infrastructure as a service is where you actually hire or create servers and the network on the cloud. PaaS is where you're not bothered about what is the underlying server and all. If you're a simple developer who wants to run your application, you simply give your code to Azure and Azure will start running it. Okay. Next thing is SaaS. SaaS, we are all using it. SaaS, there is no management. I need not write my code. I need not you do anything. For example, Gmail. Gmail is software as a service. They'll simply give you a web server. You open it and log in it. Okay. So here there is not much administration for DevOps in PaaS and SaaS. So we are going to learn IaaS, infrastructure as a service. And what are we going to learn in it? Compute. So virtual machine scale sets and images, and storage. What are the different types of storages? We are going to learn about it, and we're going to learn the networking services like VNets, subnets, routing gateways, load balancer, and DNS management. And we'll also learn how to manage access to our Azure, how to create users, roles, and groups. Okay. Again, this is a very high level view. In each of these, there's a lot to cover. For example, virtual machines itself will take at least 2 classes to cover everything, and VMS, virtual machine scale sets, and how to create images. There's a lot in each of these things. Again, these are again very high level overview for you. Okay. Next, we talked about infrastructure. For any company to run their operations, they need infrastructure. So but as I said, we need to get to market faster. So for that, we need automation. So today, you don't want to go to your Azure portal and click, and create servers. You have to do it through code. You have to use some tools to create it automatically. That's why we will learn infrastructure as code, in which we learn Terraform tool. Sorry. uh, Terraform tool and how it works and what is the language, how do we configure it. Okay. The next section is the infrastructure as code section. And the next section is source code management. How do developers write code? How do they share it in a common location? How can we retrieve the code? So as a DevOps engineer, you should also learn all these things. So we'll learn about Git and GitHub in the source code management. The next part is continuous integration and continuous delivery. So if you remember the earlier picture, right from the developers writing code to taking it to Git repository and putting into your QA stage and production servers, this is a flow. This flow has to be also automated. You cannot simply do it manually. So all this process we do it using Jenkins. How do we create a Jenkins servers? How do we deploy our software? We'll learn about it. And the next section is software configuration management. Again, if you refer to the previous diagram, we talked about uh, installing prerequisites on each of the servers. For example, to run database, you will need to have MySQL installed on it. Again, if you're creating infrastructure in terms of tens and twenties of machines, you cannot manually log into each of the servers and install software. You have to have an automated way. So SCM, software configuration management, is that utility. And I mean, software configuration management is that process. And for this, we're using a tool called as Ansible. Okay. We'll learn about Ansible in the software configuration management part. And the next section, we are going to talk about containers. Okay. Containers are the newest technology now, or not newest, they are very new technology, and everyone is going from VMs to containers. So we learn about Docker, what Docker does and how it works, how to build images and all that stuff. Okay. And next thing is, you might have heard about the term Kubernetes. Kubernetes is the bleeding edge technology everyone is trying to get onto. So this is some technology that will orchestrate your containers. It works closely with Docker. So this, I will give you a caveat. This will be a 101 course, meaning very high level overview without going into details. But I'll teach all of these things. You can, I mean, after this course, you could take some more time to learn Kubernetes. That will add to your profile. Okay. So that's on the Kubernetes part. This is going to be a very high level 101 course, not in deep dive. Okay. Right. Next, how to monitor all these things. We'll talk about monitoring and alerting tool chain. What are the various monitoring tools and alerting tools available in the market? And we'll talk about Azure Monitor, which is a service provided by Azure. We'll learn about a open source software called Nagios. How can you monitor your servers with Nagios? So why do we need monitoring? As I said, applications can go down anytime due to software issues or hardware issues. We need to have a way to get the alerts so that we go and deploy those quickly. I mean, go and restore them quickly. That's why we need monitoring, that we will cover in the last section. So that's about the course content. If you want to take at a glance, sorry, this shouldn't be AWS CloudWatch. My bad. Okay, so these are the tools we are going to learn. We are going to learn Linux. We are going to, my bad, this is Azure. This is coming from a different slide. Mm, Let me correct that real quick. So this is going to be Azure. This is going to be Azure Monitor. Okay, so overall, these are the topics we are going to cover. This is at a glance. If the earlier section was confusing to you, these are the things we are going to learn. Any questions? Let me check my chat. Docker is part of DevOps. Uh, yeah, today every DevOps engineer is required to learn about Docker, if you mean that. Or even if your organization is not using containers today, they might use it tomorrow. So if they're trying to hire someone, they might as well look for future scalability. So they'll think, okay, if I have someone who has knowledge on Docker, tomorrow when I'm going to my containerization, he would help me. So definitely yes, Docker is part of Kubernetes DevOps. So there is no specific, set of tools that we could call DevOps. It is a very high level, it's a very complex world. You have a lot of tools to learn. Okay, but I don't want to overwhelm you by giving every example, so just keeping it short. All right, so next part, this is what we learn, but what specifically is DevOps? So you might have some questions regarding that. Let's look at it. Okay, so DevOps equal to people plus practices plus tools. So that's one popular definition. We might say that this is a set of software application practices that takes the that helps the business realize their objectives quickly. But how is this achieved? Through the right set of people with the right set of skills and the right set of practices. But what if you have the right people and you also have right practices? When I say practices, policies, how you should work with dev team and all that. Will that be suffice? No, you need to learn tools, how to automate your stuff, how to make it faster. Okay. Theoretically speaking, DevOps engineer is not a role. I mean, there should not be a team called as DevOps. DevOps is supposed to be a practice. So it's a culture that aims to create better coordination between development, QA, and operations and speed up software release with utmost quality. So the quality factor should also be there. But in practice, there are job roles that are titled DevOps engineer. So if you refer to Google SRE book, it says DevOps should not be name of a team or a person. It is actually a practice. It's like a what do you call inclusiveness sort of thing. So you never. But today we have roles called as DevOps engineer. Okay, you might have seen so many things in Naukri and uh, what is that? LinkedIn and all of this stuff for requirements for DevOps engineer. That's why most of you are here. So the primary aim of adopting DevOps culture is to build and release software quickly and maintain applications with high availability and resilience. What is high availability? So how many times did you notice WhatsApp going down or Facebook going down or Google Gmail going down for a few minutes in a year? Okay. So that means they have very, very, very high availability. Okay, that's high availability. What is resilience? Resilience is, suppose WhatsApp has gone down, but how long will it take it for it to come down? A day? No, right? It's only a few minutes or a few hours at the most. So that ability to restore your service is called as resilience. So DevOps will have to always focus on faster releases and high availability and resilience. That's where all the tools we discussed earlier will come into picture. Okay. So some more details about DevOps. So what are some of the roles similar to DevOps? So site reliability engineering is something that is very close to DevOps. They also do almost the same thing. And you might also heard that you might also have heard the term cloud ops engineer. Okay, a very essential trait of a DevOps or cloud ops. So so if you're looking for job reliable, sorry, excuse me, if you're looking for jobs after this course, you could also apply for these roles based on your uh, confidence levels and also looking at the job descriptions. So a very essential trait or characteristic of a DevOps or a cloud ops or even SRE is the ability to automate repetitive tasks and minimize human intervention. Suppose today you have for client A, you have created all the infrastructure and uh, set up the required uh, environment for the deployment. Tomorrow, if client B comes, you should be able to do the same thing in a very less time using already existing tools. Okay, so that is to be able to repeatability, to create tools that you can repeat with other users as well. Okay, and another important thing, you might have talked to a lot of friends in a lot of organizations. Each of them might say different thing about the DevOps. So some people say DevOps is only about taking the code and putting in the servers. Some people might say DevOps is about running your servers and rebooting them and doing the patching. So it varies from organization to organization, and the tool set also vary. Tool set means the technology stack they are using. For instance, we are discussing here Linux, Ansible, Jenkins, and all. But there might be a company which might not be using any of the tools. They might be using Windows, and they might be using instead of Ansible, they might be using Chef or something else. But you need to understand the better picture, and even if you learn one of the tools, it's very easy to adapt to the other tools, because you'll not only learn how to use it, but you also learn the use cases and how to implement them. Okay, so suppose if I'm someone who is interviewing any one of you for a job role, and I'm looking for an engineer who has knowledge on, let's say, GitLab CI, which is similar to Jenkins, and you say you never worked on GitLab CI, but you have good knowledge on Jenkins, I will interview you about Jenkins and find out how good you are. And then I can say that, okay, this guy, even though he has not worked on GitLab CI, he can come to my organization and learn it in a short time. Okay, because no one can learn all the tools at once. You'll gradually keep on increasing. All right. So to sum it up, what 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 am I trying to say from the last 40 minutes or 50 minutes? So this course aims to introduce the application lifecycle management with emphasis on IT operations and DevOps toolchain. So our emphasis would be on the operations part and the DevOps toolchain, not much on the development. It is designed for both beginners and also experienced IT professionals, like professionals who have been working in QA or production support, or even a beginning developer who wants to learn DevOps. This course aims to equip the participants with the right amount of theoretical and practical knowledge of DevOps practices and tools. So my aim primarily would be to give you the right amount of theory and also the practical knowledge of DevOps practices and tools. Uh, this course offers a lot to learn and upskill. It is of course up to you and your appetite and how much you grab and how much you practice. Okay, because this course only aims as a gateway. It opens the gateway of DevOps. From there you need to explore, you need to learn every day and uh, understand what to do. Okay, and before we go to the Q&A session, I will give you a prerequisites. I mean, everyone asks this question, so let me put it before that. So what are the prerequisites? So minimum prerequisites, of course, you need to have a computer. Doesn't matter if it's uh, laptop or desktop. Okay, with admin rights. Why do we need admin rights? Maybe you need to install some software. Maybe you need to do something. Okay, that's why you need admin rights. Mostly we'll do it on cloud, but yeah, you need an admin rights, and you need an Azure account. Okay, Azure free tier account. Uh, the sad thing about Azure is it offers only 1 month subscription. Okay, so you should be very careful when you want to create this account. And another sad part is it requires credit card. You cannot create with a debit card for the free tier account. But if you have your friends who are already working in Microsoft or some Microsoft project, they might have some free credits. When I say free credits, they will give some amount of money to use on Azure cloud. You can ask them. Okay, and also it's since this account is for only 1 month and the course may take up to 45 to 50 days, you need to have a backup account, meaning take credit card of your spouse or your friend and create another account after 1 month, not immediately after 1 month. So backup Azure account is another requirement. I know this is tough. Most of you might not have credit. I mean, some of you might not have credit cards. I would not say most of you. Uh, so again, also to find a backup credit card and backup email account is also a problem. But yeah, that's how Azure is operating right now. And what are the additional requirements? As I said again, appetite for learning, meaning your hunger for learning, and quality time, daily time to practice. Okay, these are the minimum requirements for these things. And another question that is commonly asked is, do we need to learn coding? As a DevOps engine, everything is going towards automation, and you cannot do anything without code. So we will have to learn coding, but what level you learn, it's up to you. Everyone need not be expert on everything. You might be very good with Azure and let's say some other tools, and you have good understanding of Bash scripting. That's enough. Okay, but over here we use a lot of keyboard rather than mouse. So coding is not exactly creating new programs, but using the existing programs and modifying them. So we'll do a lot of typing in terms of when we are writing Ansible playbooks, when we are learning Terraform. Okay, when we are learning Linux, everything is command line. So you will do a lot of time typing. You would do a lot of copy pasting, of course, and not creating everything out of the blue. But yeah, it's good to have coding, but not mandatory. Okay, I think these are some of the frequently asked questions that I get asked. And again, I said the duration, it might take 45 classes, but we all take breaks, and sometimes we might have spillovers because a lot of people have questions or need some additional time. So 45 to 50 days is the course to cover all these subjects we discussed. So now I am open to your questions. This batch has been so quiet so far.
DevOps means. Hello, sir.
Yeah.
So, what is the reason we are choosing only Azure, and what is the importance of Azure over the other tools available in the market?
Uh, so Azure is one of the leading cloud providers today. AWS is still the topmost cloud provider, closely followed by Azure, and Azure has been growing exceptionally in the market. I mean, it's growing faster. So yeah, there is a lot of requirement for Azure folks. I mean, folks with Azure and also DevOps skill. Uh, that's the reason we've introduced this course. We also have AWS with Azure, AWS with DevOps course. Uh, so yeah, for people who are looking for specifically Azure administration with DevOps, this is the course.
Oh, sir, thank you.
So current yeah, Hari, you asked about Docker and container. Uh, yeah, Docker will be built in Jenkins. Yeah, you could deploy it in a virtual machine or a Docker container. We'll talk about containers are like mini virtual machines or mini computers. We can talk about it later. Any other questions? Anything about me or the course or the market? Anything? That's fine.
Hello,
Yeah,
Kiran.
yeah.
Will you teach about Kubernetes also?
Yeah, Kubernetes is also part of this course, but that will be a one-on-one course, meaning very introductory. What is Kubernetes and how you
Basic
can
or not?
install and deploy? Yeah, because Kubernetes itself is a very deep subject. You will need at least 1 month to cover all that subjects. So, but I will give
Okay.
you an overall understanding of what's Kubernetes, how you can install, how you can start playing with, and then you can start learning on your own after this course.
Okay, fine.
Yeah, hi.
Yeah, hi.
As I'm working in SQL Server administrator, can I
Mhm.
use Azure with SQL Server?
Yeah, Azure has its own offering of SQL Server. You could also install Azure SQL on Azure virtual machines. So there are something called as managed services where you don't worry about underlying software. Azure will take care of that thing. So that's Azure SQL. Yeah, you can use with it. But this course is much more than just Azure itself. We'll also talk about how to automate stuff on Azure. So there's a lot more than just Azure itself.
Okay.
Kiran, sorry to interrupt you. Hi
Yeah.
all, this is Lakshmi from Career IT. Small info from our end. The batch is starting from Monday, that is 3rd Feb onwards. The timings would be 7 to 8 a.m. IST. For USA people, it falls on Sunday evening, 2nd Feb. And I'll share you all the details clearly along with the time zones in mail. So for more details, you can reach us as a number or on mail, whatever I have provided in chat. Thank you.
Hello, Kiran.
Yep.
What difference between these AWS and Azure?
So it's as the difference between Azure and AWS is only like between Uber and Ola, to give you a very
That's
simplistic answer. Yeah, these two are two different service providers. However, you might see some changes, like some services might be costly here, some services might be cheaper there. Okay. So, or AWS might have better services for some sort of use cases. Azure might have some sort of applications for better usage. uh, AWS being the leader, it has in my experience, it has much better set of tools, and also the documentation and the process is clear. Azure is evolving in the sense it's getting better day by day.
security purpose. Azure is best. How can Azure be
So
on a security?
security works at different levels. Okay, your networking level, your application level, and all that stuff. If you look at the cloud provider level, the infrastructure level, both offer excellent security. So both have all the necessary certifications. Okay, so I haven't done the deep dive comparison, but from a very high level view, I don't see much difference. But the next is left up to the users. How do you deploy your applications? How well you manage your networks is up to you. You could deploy an application with vulnerability. Vulnerability is nothing but like giving a door to hackers where they can come and uh, install malicious software. There have been incidents on both Azure and AWS. I mean, data breach and all. Yeah, but both are actually secure. It's up to the users to manage them.
Yeah, yeah. So,
Yeah.
thank you.
Thank you.
What is the duration of the course, Kiran?
Yeah, I already mentioned it. It would be, I mean, I would need 45 classes. So we don't have weekend classes, Saturday, Sunday. So 45 classes, sometimes it might spill up to 50, 55. So you could say it's like 2 months course.
Okay, so that is like excluding weekends. So weekends
Yeah.
you. Oh,
Yeah.
okay.
Yeah.
Hey Kiran,
Hey.
this is Praveen. So
Yep.
actually, what is the role of a program in Azure? Actually, we are doing any development first, or we are maintaining after publishing.
A role of a developer in Azure.
Yeah.
It depends upon what type of application you're deploying it, and if it's something like deploying on Azure virtual machines, uh, nothing would change for him. But if it's something like deploying it in a Kubernetes, like Azure Kubernetes service, or if it's something like build using PaaS, there would be some changes that are required for him to do to adapt to the cloud. Okay, generally there is the concept of cloud native picking up. Cloud native is how do we build applications better for cloud. Okay, so that's another development aspect, but I wouldn't see much difference for a developer, but just you need to understand how the infrastructure works. It's better to understand containers and all this stuff.
Okay, fine.
All right, guys, thank you all for joining today, and you can interact with the career IT folks, and they will let you know about the other details. You all have a happy weekend. Thank you for joining today. If you want to hit up me for anything, you can reach me on Twitter. Kiran_buddy is my Twitter account. Okay, just DM
Kiran
me.
underscore.
Yeah, I put it in the chat. Kiran_buddy BADDI. He's my Twitter account. Is what I meant to say. He's not my Twitter.
Okay.
All right.
Kiran, one last question. It will be
Yeah, sure.
we are using part will be only Linux or Windows also.
So we are doing everything on Linux.
Okay, but
All the
Azure
tools
is a
we'll learn
part
on
of
Linux.
Windows, right?
No, that's a misconception. Azure doesn't care whether it's Windows or Linux. Azure is a provider of services. Whether you want to use
Okay.
Windows service or Linux service, it's up to you. And today, Microsoft says
Okay.
Microsoft loves Linux, so they're increasingly
Hmm.
focusing on Linux. In
Okay.
fact, they're getting subsystem for Windows, meaning within Windows you will have Linux in the future, maybe as a subsystem. Okay.
Hmm.
Yeah, and
Understand. Yeah.
who knows? A lot of workloads are running on Linux in Microsoft World as well. And
Okay.
some of the tools you cannot easily use it with ease in Windows. Uh, for instance, containers. Okay, these are native for Linux. When I say native, they work very well with uh, Linux, but not much well with Windows. There's a lot of work going on, but right now some of the tools are much more compatible with Linux. And also in Windows, once you learn Linux, gradually, I mean, Windows administration is easy to pick up. Linux is all command line, so it will take some time.
Hmm.
Yeah.
Okay. And I'm working as a storage admin. Is it will be
Hmm.
useful for me to come to the EMC SAN I'm working right now? Is it will be useful
Yeah.
coming for me to learn the Azure part? Like the Azure.
Yeah, definitely. Because you're already in the IT world, you have a much better knowledge than many other folks who might be new folks. So all that you need to do is learn these and practice well. And when you go out for job change, you just need to make
Hmm.
sure you have the right set of expertise to justify the
Like a migration part at the type of migration, it will be useful
yeah, both. I
because
mean,
from
if you're talking only about your current job right now, I cannot
Mhm.
comment how much it's useful. But I'm talking when you're looking for a career change from a storage admin
Mhm.
to a DevOps engineer, it would give you a
Mhm.
lot of boost. And also,
Okay.
yeah, not only that, even otherwise, it will help you understand a lot of things.
Okay.
Yeah,
Yeah. Okay. Thanks, sir.
yeah. Thanks everyone. Hopefully, we'll all meet soon.
Bye.
Bye bye.
మహేష్ బాబు వంశీ